Good afternoon, my igcse student. Today we need to solve this paper 4, Mechanics 1, October-November session 2002. Before you start your paper, you must read the instruction to candidates correctly. Look here, given that numerical answers correct to 3 significant figure or 1 decimal place in the case of angles in degrees. And when you use the acceleration of the gravity, you must use 10. It's okay? So any value of any angles in degrees, you must write the answer in 1 decimal place. When you use the gravity acceleration, use 10, and any answer in decimal form, you must write it correct to 3 significant. Now move to question number 1. Question number 1, a car of mass 1,000 kilogram travels along a horizontal straight line, a horizontal road, with its engine working at a constant rate of 20 kilowatt. The resistance to motion of the car is 600 Newton. Find the acceleration of the car at an instant when its speed is 25 meters per second. To solve like this question, we need to draw a simple model. For example, this is the horizontal road and our car. It's okay. Its resistance of motion equals 600 Newton. Suppose this vector is the direction of motion C. But now we have the power of the engine, 20 kilowatt. You must multiply it by 1,000 to change it to kilowatt only. So the power of the engine equals 20 multiplied 1,000 equals 20,000 watt. But we need the force of the engine. The force of the engine, F, equals, if you multiply the force by V, equals the power of the engine, 20,000 watt. And here the velocity of the car is 25. So to find the force of the car, you must divide 20,000 by 25. So F equals 800 Newton. So now we can say the force, we can say here, the force of the car equals 800 Newton. F here equals 800 Newton. The force of the car equals 800 Newton. It's okay? Okay. And the remark here, the mass of the car equals 1,000 kilogram. All of you know that the direction of the weight force is vertically downward. So the weight force will be the mass 1,000 multiplied by the gravity, which is equals to 10. It's okay? Equals 10,000 Newton. But to find the acceleration, we can use the second law of Newton. The resultant of all forces acting on the body in the direction of motion, it's okay, or in the opposite direction of motion, equals the mass of the body multiplied by the acceleration of motion. What does it mean? Means the force of the engine minus the resistance 600 equals the mass of the car 1,000 multiplied by the acceleration of motion, which is A. And now to find A, you must subtract 800 minus 600 gives 200, divide by 1,000, which is equals to 0.8. So the acceleration of the car equals 0.2 meter per second squared. The next question number 2. we have the graph, the diagram of velocity time. And all of us know that this graph, we can find the covered distance when you calculate the area under the graph. This means you have the covered distance. It's okay. This graph, look here, the velocity, the maximum velocity here, 7, and the interval of time starts from 0 to 40 from the graph. A man runs in a straight line. He passes through a fixed point A. When its velocity 7 meters per second, what does it mean? Means this point is A. It's okay. At time t equals 0, we can say also this point is A. At time t, s means a second, his velocity is v, meter per second. The diagram shows the graph of v against t for the period from t between 0 and 40, or start from 0 to 40. The first item shows that the man runs more than 154 meters in the first 24 seconds. It's okay? Okay. So now, to solve like this question, you must understand the graph correctly. How? In the first 24 seconds, we have two parts. The first part from 0 to 20. The second part from 20 to 24. Look here, from 0 to 20, we have a rectangle. So, to find the covered distance from the first interval from 0 to 20 means the area of the rectangle. So, to solve the first item, firstly, we find the area of rectangle equals width multiply length. So 7 multiply 20 equals 140. But to find the covered distance in the next interval from 20 to 24, it's so difficult. Why? We don't have a regular shape. But now we can draw this triangle and we can find the area of this triangle. The area of the triangle equals its base from 20 to 24 means 4. Its height is 7. Divided by 2 gives 14. What does it mean? It means the area from the area of this rectangle and this triangle will be equals 120 plus 140 plus 14 equals 154. But remark, we have also another part, we didn't find its area. What does it mean? It means we have an area greater than 154. As the area of this part only, 154. But we have another part, we didn't find its area until now. What does it mean? It means the area under the curve from 0 to 24 greater than 154. It's okay? So the area greater than 154. The next, the second item, double I, given that the man runs 20 meters in the interval from 20 to 24. It's okay? In the interval from 20 to 24, we suppose now the area of this part is 20. It's okay? And the area of the rectangle is 140. We found before. That's okay. Given that the man runs 20 meters in the interval from 20 to 24, how far? Find how far he is from A when t equals 40. We need to find the distance between the body and the point A after 40 seconds. So what does it mean? You must find all covered distance and add all of them. The rectangle is, the covered distance using a rectangle means 140 plus 20. And the remark here, from 24 to 30, from 24 to 30, the V, the velocity equals 0. What does it mean? Means the body is at rest, no covered distance. But to find the covered distance from 40 to 30, you must find the area of the triangle. So we need now to find the area of triangle. Area of last triangle, which is equal to base equals 10, multiplied by height equals 8, divided by 2, so equals 40. So the total covered distance, which is equal to 140 plus 20 plus 40 equals 200 meters. So the distance between the body after 40 seconds and the point A equals 200 meters. It's okay? It's okay. Move to question number 3. Question number 3. A light and extensible string has its end attached to two fixed points A and B, with A vertically above B. A smooth ring R of mass 0.8 kilogram is threaded on the string and is pulled by a horizontal force of magnitude x newtons. The sections AR and BR of the string make angles of 50 degrees and 20 degrees respectively with the horizontal. As shown in the diagram, the ring rests in equilibrium with the string taut. Then find item 1, the tension in the string, the second item, the value of x. It's okay. It's okay. Look here. The first point, the mass of the ring equals 0.8, and all of us know that the weight force vertically downward, so W, the weight force of the ring, equals 0.8 multiplied by the gravity, which is 10, so equals 8 Newton. By resolving the two tensions in the two string, look here, look here, the first tension is T and the second tension is also T. Why? As the ring is smooth. So the two tensions are equal. Now we need to resolve the first tension and the second tension in the vertical direction. So this component, vertical component of the first tension equals T cosine 40. Why cosine 40? We have this right angle triangle, this angle 50, so this angle will be 40. By the same way, this angle is 90, 20, so this angle will be 70. This means that the vertical component of the tension act at point B will be T cosine 70. It's okay? By this way, we can say all forces upward equals all forces downward. What does it mean? It means that the force upward, T, vertically upward equals T cosine 40 equals what? The all forces acting downward equals T cosine 70 plus the weight force. By this way, we can find the tension by taking T as a common factor. So T multiplied by cosine 40 plus cosine weight, Yeah. Now, we can take T cosine 70 from right to left with the negative sign. So the equation will be T cosine 40 minus T cosine 70 equals 8. By taking T as a common factor, we can say T between bracket, open bracket, cosine 40 minus cosine 70 equals 8. So the tension will be 8 divided by cosine 40 minus cosine 70 equals, so the tension will be equals, using your calculator, 18.9. Why 18.9? As we need to write the answer as a decimal point corrected to 3 significant. It's okay? The next step, we need to find, this is the answer of I, item I. Item double I, we need to find the value of X. The value of X. It's okay? From the resolution of the two tension, it's okay, on the horizontal direction. So here we have the first component, T sine 40, and the component of the tension at B equals T sine 70. So the all forces in the right equals all forces in the left, Y, as the ring is in equilibrium. This means X equals T sine 40 plus T sine 70, and substitute for T using 18.8, and using your calculator you will find X equals 29.9. Note. It's okay. The next question, question number 4. Question number 4. Two particles A and B are projected vertically upward from a horizontal ground at the same instant. The speeds of projections of A and B are 5 meters per second and 8 meters per second, respectively. Then the first item, I, we need to find the difference in the heights of A and B when A is at maximum height. By the same way, we draw a simple model for this example. Look here. This is particle A, this is particle B, and the motion is vertically upward. What does it mean vertically upward? It means opposite to the gravity direction. This means the gravity acceleration will be negative 10. It's okay? So here, A will be negative G equals negative 10. It's okay. Respect to the particle A, the initial velocity U equals 5. The initial velocity respected to B, U equals 8. But now we need to find the difference in heights of A and B. When? At its maximum height. What does it mean maximum height? Suppose A moved vertically upward and stopped at this point. This point will be maximum height. Maximum height means the terminal velocity will be 0. So, respect to A, we have the initial velocity, we have the terminal velocity, and we have the acceleration also, the gravity of the acceleration, which is equal to -10 in the opposite direction of the gravity. So now we can find the distance and the time also. The distance, we need to find the height of the particle A. And to find the height of the particle B at this moment, we need to find the time of A to reach to its maximum height. So remember that we have the equations of motion in the direction V equals U plus AT, the second, V squared equals U squared plus 2AS, the third, the quadratic equation in time, the distance equals UT plus half AT squared. It's okay? But now we need to find what? We need to find the time. The required time for particle A to reach its maximum height. So here V, we can use this equation. V equals 0. So 0 equals 5. And the A, the acceleration here means -10, means G in negative, -10t. By solving this equation, t equals half second. This means that the particle A reached to its maximum height after half second. And now also we need to find its distance. It's okay? To find the covered distance, we can use the second equation, no problem. 0 power 2 equals, the initial equals 5 power 2 means 5 power 2, minus 2 multiply 10, which is 20, S. By solving this equation, S equals 25 over 20, which is equal to 5 over 4 meter. So respect to the particle P, respect to particle B, we need to use the time equals half to find its height after time equals half. It's okay? So we need to find the height, means the distance. We can use the quadratic equation in velocity, V power 2, we need V power 2, and what? No, it's better to use the equation, the quadratic equation of the time. So S equals, U means the initial of B, which is equal 8, multiply the time, half, minus half multiply 10, multiply half squared, which is quarter. And now we can find S. S equals 4. And here minus what? Divide 5 over 4. 4 minus 5 over 4 equals 11 over 4. Now we have the heights of particle B and the heights of particle A. To find the difference between the two heights, we can subtract. We can subtract. So here, to find the difference, we can say the difference delta S, the difference of heights, equals what? 11 over 5 minus 11 over 4. Again, the difference in heights, the difference in height delta S, which is equal to 11 over 4, 11 over 4 minus 5 over 4, which is equal to 6 over 4, 6 over 4, which is equal to 6 over 4, and 6 over 4, 6 over 4 equals 3 over 2, which is equal to 1.5 meter. It's okay? So the difference between the two heights equals 1.5 meter. The second item, double I, we need to find the heights of A above the ground when B is 0.8 above A. 0.8 above A. It's okay? Yeah. To solve like this item, we need blank area, so please wait. To solve the second item, look here. We need to find the height of A above the ground when B is 0.9 above A. What does it mean? Look here. Suppose this is A and this is will B, and the difference between them equals 0.9. It's okay? Yeah, second item, like this figure. We need to find the height of A when the body of B is 0.9 above A. Look here. The particle A reached to this point and the particle B reached to this point at the same time. It's okay? So T here is common. And they're required to find or to use the distance. So it's better to use the quadratic equation of time to find the distance. We say, for example, the distance respected to A is SA. SA equals what? From the equation, the initial of A is 5t minus what? The equation have at squared. A means negative 10. So half 10 means 5 t squared. And respect to B, SCB, its initial equals 8t minus 5t squared. It's okay? But now we need to find the difference between the two heights. So you must subtract what? SCB minus SA. So we can say SCB minus SA equals 3t. And SCB minus SA equals 0.9 as a given. So 3t equals 0.9 implies to 0.9 implies to 3 implies to t equals, divide both of sides by 3, so t equals 0.3 equals 0.3. Now we can move to question number 5. Question number 5, to understand it, you must read the question correctly. Question number 5, we have a figure. This figure is question number 5. A force whose direction is upward parallel to the line of the greatest slope of a plane inclined to 35. It's okay? Again, a force whose direction is upwards parallel to the line of the greatest slope of a plane, inclined to 35 to the horizontal, acts on a box of mass 15 kilogram, which is at rest on the plane. The normal component of the contact force on the box has magnitude R in this figure. The first item show that means you must find this number, you must find this answer. It's okay, you can't find any number else. Show that R equals 1, 2, 3. Correct 2, 3 is significant. It's okay. To solve here the first item, the mass of the force, please, 1 minute. To solve item I, or the first item, firstly you must understand the mass of the body is 15 kilogram, so the weight force will be W equals 15 multiply 10 equals 150. It's okay. And we can resolve the weight force into perpendicular direction. The first vertically to the plane, which is equal to 150 cosine 35, and the second in the greatest slope of the plane downward, which is equal to 150 sine 35. That's okay. Now we need to find the value of R. It's okay. All forces in the perpendicular direction to the motion are in equilibrium, and we know this fact. So R equals 150 cosine 35. Using your calculator, so R equals 122.9, corrected to 3, significant will be 1, 2, 3. It's okay, 1, 2, 3. The next, figure 2, when the force parallel to the plane acting on the box has magnitude x newtons, the box is about to move down the plane. And when this force has magnitude 5x newtons, the box is about to move up the plane. Then we need to find the second item. Find the value of x and the coefficient of the friction between the box and the plane. Firstly, you must know the difference between the figure number 1 and the figure number 2. Here, when the force is x, the body is about to move down. What does it mean move down? Firstly, put here 150 cosine 35 and 150 sine 35. Then when the body is about to move down, means the friction force acting upward, not downward. Acting upward. Why? As the motion will be downward. Suppose this vector is the direction of motion. So here we have the friction force will be upward. Friction force is suppose is F. Now the equation of motion respect to this figure equals what? X plus F equals 150 sine 35. In the second figure, when the force is 5x, mean the motion will be upward. What does it mean? Means the friction force will be downward. Don't forget the component of the weight, 150 sine 35. According to this figure, we can say 5x equals the friction force plus 150 sine 35. From the first equation, we can say x equals minus F plus 150 sine 35. The second equation, 5x equals F plus 150 sine 35. By adding the two equations to get 6x equals negative 5 positive 5 gives 0, and now 150 sine 35 plus 150 sine 35 equals 300 sine 35. Divide all by 6 to get x. So x will be 50 sine 35. Using your calculator, the answer will be 28.7, corrected to 3 significant. It's okay? Yeah. But we need to find also the coefficient of the friction. Coefficient of the friction means mu. We have a relation between the friction force and the normal reaction. The friction force, which is F, equals mu r. Equals what? Mu r. Okay? And r, mu, and r equals 150 cosine 35. So now we need to find the mu. We can substitute F equals mu 150 cosine 35 in this equation number 1. It's okay? Or in this equation, it's better. And substitute for x using 28.6. So from this equation, we can say F equals 150 minus, 150 sine 35 minus x equals 28.7, and replace F with mu r, and r 150 cosine 30, so we can say F here equals mu 150 cosine 35, which is equal to 150 sine 35 minus 28.7. Divide all sides with 150 cosine 35, so mu equals 150 sine 35 minus 28.7 all over 150 cosine 35. So mu using your calculator equals 0.467, corrected to 3 significant. It's okay? Yeah. Move to question number 6. Question number 6, first item, I. A particle P of mass 1.2 kilogram is released from rest at the top of the slope and starts to move. The slope has a length of 4 meters and is inclined at 25 degrees to the horizontal. The coefficient of the friction between P and the slope is quarter. Find what the first A, the frictional component of the contact force on P. We need, By the same way, to solve like this question, we need to draw a model. And to put all forces on the graph. For example, this is the ground, the horizontal, and this is the inclined plane. Inclined to the horizontal with angle 25. It's okay. And this is our particle. The force is upward, and the weight is 1.2 multiplied 10, which is equal to 12 Newton. It's okay. Look here, the particle P of mass 1.2 is released from rest. What does it mean? Its initial velocity u equals 0. And also, the slope, its length equals 4 meters, means the distance from the top of the slope to the bottom of the slope equals 4 meters. It's okay, the covered distance. And the friction, mu equals a quarter. It's good. And look here, the body is released downward. What does it mean? Means the friction force is upward. Don't forget the component of the weight downward at the greatest of the slope equals 12 sine 25. And don't forget R, normal reaction, and the component of the weight in the opposite direction of R, which is equal to 12 cosine 25. It's okay? Now we can use the motion equation. What does it mean, the motion equation? The body will move downward. So, using the second law of Newton, the component of weight downward minus the friction force equals the mass multiplied by the acceleration of motion. This means 12 sine 25 minus F equals MA, means 1.2A. But remark, R equals 12 cosine 25. 12 cosine 25. And F equals mu R, which is equal to quarter multiplied by 12 cosine 35. So F equals 3 cosine 35. Replace F with 3 cosine 35 to get 12 sine 25. Sorry, this angle is 25, not 35, by the way. 25. 12 sine 25 minus the value of F3 cosine 25 equals 1 1.2a. 1.2a. So divide both of sides by 1.2 to get a equals 1.96. Correct 2, 3 significant. By the way, this is item B. But item A, the frictional force, which is R. R now equals 12. R equals 12 cosine 25. 12 cosine 25. We need to find the frictional component. Okay. Go to frictional component here is A. This is item A. Equals 3 cosine equals 2.72. Corrected to 3 significant. It's okay. Now we need to find the item C. The speed with which P reaches the bottom of the slope. To find item C, we need to find the speed of the particle at the bottom of the greatest slope. Means after covered distance equals 4. After covered distance equals 4. So we can use this formula, V squared equals U squared plus 2AS equals U equals 0 as the body released means start from rest means U equals 0. So here V power 2 equals 2 multiplied by 1.96. It's okay, the value of the acceleration multiplied by 4 the value of S. By taking the square root to both of sides, so we can say V equals 3.96. Correct meter per second, corrected to 3 significant. It's okay. It's okay. Now move to question number 7. Question number 7. A particle starts to move from point O and it travels in a straight wait. Stop here. Yeah. We forgot double I. We need to solve double I. Sorry. Before start solving question 7, we need to solve double I. At question number 6. To solve double I, read it. After reaching the bottom of the slope, B moves freely under the gravity. It's okay. Yeah. What else? Freely under the gravity and subsequently hits the horizontal floor, which is 3 meters below the bottom of the slope. A, find the loss of the gravitational potential energy of B during its motion from the bottom of the slope until it hits the floor. The second, find the speed with which B hits the floor. What does it mean? Means the body reaches to the bottom, then move freely under the gravity to reach to the floor. It's okay. And this distance is vertical distance, which is equal to 3 meters. Which is equal to what? 3 meters. Don't forget that the last velocity, or the velocity of the body at this point is v equals 3 point. Wait, the speed of the body, we found it before. Yeah, we found it before. The speed of the body at the bottom, v power 2 equals 15.68. It's okay? Yeah, so to move under the gravity, the body will start with this speed. And here, g will be positive 10. And the cover distance to the floor is 3 meters. The first item, item A, we need to find the loss of the potential energy, means delta E, which is equal to mgs. mgs equals 1.2 multiply 10 multiply 3 meter equals 36. Equals 36. 36. The second item B, find the speed. It's okay. To find the speed, we need to find the last velocity at the floor, which is V. So V power 2 equals U power 2 means the last velocity at the bottom of the slope, which is equal to 15.68 plus 2 multiply 2as, means 2 multiply 10 multiply 3. 2as from the equation. V power 2 equals U power 2 plus 2as. Then using your calculator you can find V equals 8.70. Corrected 2, 3 significant. Don't forget 0. Now move to question number 7. To solve question number 7, read it correctly. A particle P starts to move from a point O and travels in a straight line. At a time t second after P starts to move, its velocity is v meter per second, and the equation of the velocity in general equals 0.12 t minus 0.0006 t squared. The next, we need to verify that P comes to instantaneous rest at t equals 200, and define the acceleration with which it started to return towards O. Okay, we need to verify that B comes to instantaneously or instantaneous rest. What does it mean? Means V equals 0. So to solve first I, V equals 0. Solve the equation 0.12 t minus 0.0006 t squared equals 0 by taking t as a common factor and solve. So we have t between brackets 0.12 minus 0.0006 t all equals 0. So we have t equals 0 and t equals 0.12 all over 0.0006. So t equals, from this equation, t equals 200 second. 200 watt second. That's okay? Yeah. Then the second part of this item, find the acceleration. It's okay. To find the acceleration, differentiate V. So A will be what? 0.12 minus 0.12. It's okay. when you differentiate it, minus 0.0012 t. It's okay? And look here, the acceleration with which it will start to return towards 0 means put the acceleration equals 0, then t equals what? 0.12 all over 0.0012, which is equal to 100 seconds. The next, double I. Find the maximum speed of B for the time start from 0 to 200. The maximum speed. It's okay? So to find the maximum speed means the acceleration equals 0. The acceleration equals 0. The acceleration equals 0 means A equals 0 gives T equals 100, as we said before. The triple I, the displacement of B from O to, or when T equals 200. We need to find the displacement of B from O when T equals 200. It's okay? Yeah. The displacement is the integration of the acceleration. 0 from 0 to 200, 0.12 t minus 0.0006 t squared by dt, which is equal to 0.06 t squared minus 0.0002 t power 3 from 0 to 200, which is equal to 800. It's okay. And the last one, IV. We need to find the value of T when B reaches O again. Reaches O again means S equals 0. Means S equals 0. It's okay. S equals 0. Displacement equals 0. So the displacement here equals 0. What does it mean? It means 0.06 t squared minus 0.0002 t power 3 equals 0. By solving this equation, t will equal to 300 seconds. Thank you very much. Goodbye.